Welcome to Unit 8.6. Today is day 1 of completing the square. So we are going to lay the foundation today for another method for finding the roots of quadratic functions. So completing the square is no joke. We're going to be looking at this for a minimum of 3 days. Okay, we're going to take it nice and slow. But we have to make sure that we get this foundation laid down so that we can understand the process tomorrow when we actually go to solve. Okay, so we're going to start with something that looks like this. So how would you go about trying to solve this function, solve this equation? So we see that our variable is inside the parentheses that are being squared. Okay, so if your gut instinct here is to say, well, take the square root of both sides, okay, you would be correct, all right? By taking the square root on the left, the square and the square root cancel each other out, and we're just left with that m plus 2 in parentheses, which is what we're trying to accomplish. Now on the right side, when we take the square root, we have to be very, very careful to remember that that is actually equal to positive and negative 6. Okay, why is that? Because negative 6 squared and positive 6 squared both equal 36, because if we use parentheses and order of operations appropriately, they both come out to be that positive 36. So we have to account for both of those options on the right. So what does that mean? We now solve two separate equations. M plus 2 equals 6. M plus 2 equals negative 6. Okay, we were able to solve that by taking the square root on both sides. Okay, same setup. We're going to try the same thing. Take the square root. Okay, so lucky for us, on the left side, the square root and the squared will cancel. We'll get that p minus 4 in parentheses. Well, now on the right, I don't know the square root of 3. Okay, and we always leave non-perfect squares inside the radical, inside that square root symbol, so that it's exact and we don't have that great big ugly decimal. Okay, so instead, we're going to leave this as plus or minus the square root of 3, all right? And we need that plus or minus just the same that we did in the previous example, okay? Because each of those values, the positive and the negative squared, will get us back to 3. Okay, so now we have two equations we need to solve. So it equals the positive square root, and it equals a negative square root. All right, that plus and minus stays on the outside. That does not go in the square root. So pay attention to how we solve this. When I add 4 to each side, okay, the square root and the 4, those are very clearly not like terms, which means they do not get combined. So we instead just have two separate terms written together with addition, very similar to literal equations. When you have those multiple variables, you can't actually put together. And the same thing on the negative side. So negative square root of 3 plus 4. Okay, and those are our two answers. We leave them just like that. Okay, and that's perfectly fine. Now, that's something called the squared property, the square root property, when you take the square root of both sides. All right, well, that makes sense. However, it only works when the problem is written in squared form. So that's these parentheses with a squared on the outside. Okay, now sometimes it'll already be written in squared form. Sometimes we have to put it into squared form. And the only way that we can convert it into squared form if it's something called a perfect square trinomial. So we want to see, well, what does a perfect square trinomial look like, and how do I turn it into squared form when necessary? Okay, so a perfect square trinomial is created by foiling. We saw foiling in Unit 6 when we multiply two binomials together that are the same thing. So like x plus 5 times x plus 5. When we foil that, okay, we get this equation down here, x squared plus 10x plus 25. Okay, so this is an example of a perfect square trinomial. Well, what makes it a perfect square trinomial? Okay, the last term is a perfect square, 25. Okay, that has to happen. The middle term has to be twice the square root of the last term. Okay, so let's say that again. So if we take the square root of 25, we get a 5. So 10 is double 5, or 2 times 5. We have to have that relationship between the middle and the last term. So whatever the square root is here on the end, if we double that, we should get the middle term. The way that we write these in squared form, okay, we take a shortcut because we're going to be able to recognize that pattern. We're going to take a shortcut and we're going to do something called half the middle term. Okay, go with me for a minute. So let's take a look at an example. All right, so I have here, I have a trinomial, okay? Now, every other time that we've solved an equation, we've always said bring everything to the same side. But we don't want to do that here. We want to leave everything how it is because we're looking to see, do I have this special case, this perfect square trinomial on the left? So I'm going to check. Okay, is my last term a perfect square? Yes, it's 49. Okay, so what is the square root of 49? That equals 7. Is my middle term 2 times 7? Yes, it is. It's 14. Okay, so this is in fact a perfect square trinomial. Yes. So how do I factor this into squared form now? Okay, we want to go into squared form. And what does that look like? Remember, it's x plus or minus. So in this case, it's going to be a plus because this is plus. X plus a number, and then that whole thing is squared. So that means that when you do the big X here to factor, that we're getting the same factor twice. What multiplies to 49 and adds to 14? It's 7 and 7. So if we grouped that, we would get x plus 7, x plus 7. Okay? I don't have time to do the big X and to group and to factor that. That's why I want to take the shortcut. And for perfect squared trinomials, that shortcut is always going to work. Okay, so we take half the middle term. So my middle term here is 14, and we're going to half that. It's 7. So 7 is going to be the value that we plug into our squared form. It's going to work every single time. X plus 7 squared. There it is in squared form. equals to 64, because now I can do the square root property like we were doing in our first two examples. I get x plus 7 on the left, and I get plus or minus 8 on the right. You have to remember the plus or minus, because you need two equations to solve. You can't get two equations any other way. Okay, and those are my two answers. Let's try it again. So we're adding an extra step here to the first two examples where we did squared form or square root property. We now have to write it in squared form first. Okay, so I have another trinomial. I'm going to check. Is it a perfect square trinomial? All right, so is my last term a perfect square? Yes, it is. It's 25, right? And we're going to figure out what's the square root of that. It's 5. So now look at your middle term, and you can disregard the sign. 2 times 5. You're taking the square root from over here. That's where that number comes from. 2 times 5, does that match my middle term? Yes, it does. The middle term is 10. Okay, so in squared form, it's going to be x minus a number this time, because this is a negative right here. We always base it off of that value. If you noticed in the last example and in this one, okay, the third term of the trinomial, the one that we checked to be a perfect square, it's always been plus. Okay, and that's not a coincidence. All right, so we take half the middle term. So the middle is 10. Half that is 5. So squared form for this one will be x minus 5 squared. Okay, and that's going to equal 12. Remember, we don't move the number to the other side on this one. Okay, and we're going to square root property now. Okay, so how do I know I don't move 12 to the other side? I'm looking at the directions. When the directions say solve using the square root property, that means you do not set equal to 0. So we get x minus 5 equals, this is going to be plus or minus the square root of 12. Okay, before I split this into two equations, I can simplify this square root. Square root of 4 times square root of 3. Okay, that equals, 2 square root of 3. Okay, so when I split this up, I'm going to use that simplified radical. So positive and then negative. Okay, and solve. So remember, these are not like terms. So we're just going to leave them as adding two separate terms. This is my washing machine, if you heard that. Okay, so those are our two answers. Okay, this was definitely a more complicated example. We had to simplify that square root. When we split that up, okay, we had to get that squared form. All right, try one more of these. If you want to pause your video and you try and solve this, now is a great opportunity. All right, so the left side here is a perfect square trinomial. I have 144. It's a perfect square. The square root of that is 12. Okay, and 2 times 12 equals 24. Okay, which is my middle term. So I'm going to half the middle term. So the middle equals 24. Half of that is going to be 12. So 12 is the number that I take into my squared form. So x plus 12 squared. Okay, if you're having trouble taking that shortcut into squared form, okay, you can start by doing the big X, grouping, and factoring it. Okay, and perhaps after you do it that way a couple times, you'll start to see the pattern, and then you can take the shortcut. All right, so square root property here on both sides. And I notice on the right, okay, I have a negative square root, and I have to break that down. Okay, so negative 18 is going to be negative 1, be negative 1 times 18, and then 18, I'm going to do 9 and 2. Okay, so square root of negative 1, square root of 9, square root of 2 equals 3i root 2. Okay, a lot just went on there. Okay, take a second, rewind, redo that. So split up the 18. You first have to take out the negative because we know that's going to be imaginary. We saw that in quadratic formula. Okay, then we break down 18 using the biggest possible perfect square, which is 9. 9 times 2. Each one of those goes in a square root. We only know the square root of negative 1 and 9. So we take those out. We don't know the square root of 2. That stays inside the radical. All right, so we could take a second and just put it back in as that simplified plus or minus 3i root 2. Okay, and then we're going to split it up into two equations. One where it's positive and one where it's negative. All right, and then we'll solve by subtracting 12. Remember, those are not like terms, so they cannot be combined. We just write them out using the appropriate operation. Okay, think of them as if they are different variables. Okay, you know you can't put together two different variables. The fact that it's a radical makes you unable to combine them. Right, and those are our final answers. Definitely a much more complicated example here with that negative 18 under the radical. Okay, there's a lot of steps. So unfortunately, when we get a problem, they're not always going to be those perfect square trinomials. That might not check out every single time, and then we can't write it in squared form. And if we don't have squared form, then we can't take the square root on both sides. So there has to be something we can do to accommodate and to turn every run-of-the-mill problem into this special case of a perfect square trinomial. Okay, so what can we do? It's something called completing the square. So we're just touching on how to start that process of completing the square right now. Okay, so we use a formula and we find a new c value. Okay, so ax squared plus bx plus c. So that c is what we look for to be the perfect square. So if we use this formula and we plug in a new c value, we can turn any old equation into a perfect square trinomial. Okay, so we take b over 2, that's the middle, and then we square it. Okay, so let's see this in action, and let's calculate a couple of those c values. Right, so here we have all these equations. Well, what value would we have to put in each one of these blanks, okay, to make it a perfect square trinomial, to follow those rules that we check every time we go to solve a problem? So we're going to use the formula that we just saw in the previous slide. C equals B over 2 squared. Okay, so C equals 12 over 2 squared. So 12 over 2, 12 divided by 2 is 6. Square that is 36. Well, 36 is a perfect square. Put it in that blank. Perfect square, the square root of that is 6. 2 times 6 matches the middle term. Voila, perfect square trinomial. Let's try it again. Negative 8 over 2 squared. So this is a negative 4 squared using parentheses. Okay, we get positive 16 when we square that. We know 16 is a perfect square. The square root of that is 4. 2 times 4 equals 8, which is my middle term. Again, this is checking out. All right, these last two examples are going to be fractions because I can't do 5 divided by 2, and we do not use decimals. We must use fractions for all of completing the square. So how do we square a fraction? You square the top number and square the bottom. So you get 25 over 4. And we leave it as a fraction. Okay, and this very last one. So b over 2, negative 9 over 2 squared. Well, that does not divide. So negative 9 squared is 81. 2 squared is 4. That's your C value, and that makes this a perfect square trinomial. Okay, so let's recap what we did here today. We learned square root property, where we square root both sides of the equation and solve. We learned how to identify a perfect square trinomial and to turn that into squared form. And now we've identified how to take any old equation and turn it into a perfect square trinomial by using this formula at the top, C equals B over 2 squared. Okay, so that is our foundation for completing the square. These are all skills that we're going to need. We're going to put them together for one whole process. Okay, but we need to make sure that we have these 3 things that we just went over today, mastered before we move on. All right, so make sure that your notes are complete. If you have any questions, please write them down so you don't forget to ask during class when we go over this. All right, that is the end of day 1 here. Thank you so much for watching, guys. I will see you